Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time, and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop, and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures: mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next Ice Age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
Yep, there's ice all around, as far as the eye can see. A white desert covers the entrance to your cave, the one where you and a bunch of other settlers live. Everyone's gathered around a fire pit, trying to keep warm, telling each other stories about how much snow they saw the other day. Some are running around playing tag, throwing sticks, whatever people used to do for fun 300,000 years ago. You're one of the earliest Homo sapiens to ever walk the earth. Others are sleeping or just resting their eyes. All around the cave, all you can hear are stomachs rumbling, sounds like a wild animal lurking around. You look out the mouth of the cave and see that the storm has cleared. Time to grab some tools and head out as a group. In the open wilderness, you find some berries covered in snow and plants that might be edible. But it's not enough to feed the whole tribe. It's the Ice Age, and there's not much vegetation growing anywhere. One of your friends spots some large footprints in the snow. The chase is on. You can't tell what it is, but it should be enough to feed everyone for a couple of days. As you go deeper into the snow-covered forest, you hear a growl behind you. You hope it's your stomach, but you look behind you and suddenly black out. An ice age is a period when large sheets of ice cover everything, changing the Earth permanently. It's partly responsible for the raising and lowering of sea levels, as well as the current layout of the continents. Picture monster-thick ice sheets spread across what's now Canada, Scandinavia, Russia, and even South America. That's all caused sea levels to change drastically, and temperatures around the world fell dramatically. And I'm not talking about just one ice age. There were a bunch of them. Scientists say there have been 5 major ice ages throughout history, lasting for millions of years. And we're in the middle of one right now. Relax, don't panic. It doesn't mean we're all going to be sleeping next to bonfires, trying to keep warm after being out all day looking for woolly mammoths. And no, there won't be a massive geological ice storm that freezes everything in its path. Ice ages have warmer periods in them that come and go, lasting for tens of thousands of years. In fact, billions of years ago, the Earth was one giant snowball with no life on it. And the sun back then was also just a cute little fireball without enough heat to melt all that ice. But as the sun got bigger and hotter, Earth's ice slowly melted away, leaving the green and blue ball we have today. We're living in the Quaternary Ice Age that's been going on for the past 2.6 million years, and counting. Some animals have thrived in this latest ice age, like whales and sharks. They've been at the top of the food chain for ages. Under them are seals, certain kinds of fish, otters, all the way down to tiny plankton. Up on the cold surface, mammals had to grow thick and shaggy fur just to stay warm. Ancient mammoths, rhinos, and bison were known to have thick rugs on them. They looked awesome. They were herbivores and ate small shrubs and whatever grass they could find. But several thousand years ago, temperatures began to rise, and most of these animals became extinct. The ones that remained evolved into the elephants, hippos, and rhinos we have today. You wake up from your blackout and find yourself face to face with a creature that kind of looks like a modern-day bobcat, except it's much bigger and furrier. It's a smilodon, an epic version of a saber-toothed cat with a mean look. It's around the same size as a male lion and has 2 front fangs that make me think twice before leaving the safety of my cave. They look scary, but scientists think their bite wasn't as powerful as today's tigers or lions. What made them tough were their giant forearms used to wrestle down anyone who got on their nerves. In packs, they were even able to take down mammoths. Either way, you don't want to be waking up next to this kitty. It's staring you down, ready to pounce. But you and your friends keep calm and slowly back off. You get the genius idea to throw a rock to distract it, then run. Nowadays, it's near impossible for a human to outsprint a lion or tiger, but humans back then were much fitter. Once the danger's over, everyone continues to look for food. It's getting dark, and you haven't found anything to bring back to the cave. Suddenly, you smell something burning. Way off in the distance, you see a thin column of smoke rising into the sky. Another settlement? You and your friends look at each other and approach the smoke cautiously. Homo sapiens first came into being about 200 or 300 years ago, but human history didn't just pop up out of nowhere. As far back as 7 million years ago, some of us decided to call it quits. We left our chimpanzee ancestors in the jungle and started doing our own thing. And that didn't just happen once. Over those next millions of years, there were over 20 different human species. Some were our ancestors, some were twigs from a completely different branch. Some were tiny, others better adapted for hot or cold weather. Before you know it, you see a group of Neanderthals cooking some meat, sharpening their tools. Neanderthals were the first to migrate to Europe. Scientists believe they were around somewhere between 40,000 to 400,000 years ago. They occupied all areas between Europe and Asia, while Homo sapiens, that's us, were still all the way down in Africa. You enter their camp and immediately see the differences between each other. They're stocky and look a bit different, but there are some similarities, like flat teeth for chewing and gnawing and big skulls for their big brains. They even have clothes on, like you. According to archaeologists, they lived in shelters and made tools out of stone, sticks, and bones. They welcome you inside and give you a tour like no other. You're officially meeting another human species. They take you inside their cave and show you some of their cave paintings. They were the first artists of their time. Many of their galleries are still around today, like the ones in caves in Spain. You know their style: minimalist paintings of deer, a large handprint. They also dabbled a bit in jewelry making. They made necklaces out of eagle talons and animal fangs. They were also probably the first ones to harness the power of fire. Did they discover it when a bolt of lightning hit a tree? Or when one of them dropped a rock on another rock, creating a spark? No one really knows. But they were able to recreate it and use it to keep warm, to cook food, to see in the darkness, and to protect themselves. After the nice tour, you hang around the campfire to keep warm. They even offer you some extra clothes for the journey home, mostly thick, shaggy mammoth coats. If only you could talk to each other, that would be awesome. But it's getting dark, and you need to head back to the tribe. You say your goodbyes and thank them for teaching you how to draw a deer, and for that sack of food they gave you. The Ice Age was important for the development of the modern Homo sapiens. Because of the extreme cold and other harsh conditions, they had to adapt to survive, be extra clever and innovative. They developed advanced tools and even used bone needles to sew warm clothing. They may have hosted the first ever runway show. When the climate started to get warmer, they developed farming techniques to sustain themselves and mainly settled near large bodies of water like rivers or lakes, while others opted to be near seas and oceans. We, were even the first to domesticate animals. Fast forward a few 100,000 years and here we are.
Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's gonna be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Ediacaran fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our Sun. Can you imagine that? It's so enormous that if we could somehow replace our Sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time.
Yep, you heard it right.
Betelgeuse is about 600 light years away from us, so the light we see today actually left the star 600 years ago.
It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink, but just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shockwaves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, "Hey, look at this amazing spectacle. How dangerous will it be for us?" Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows, your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space. Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty bam! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases! Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during the second experiment. Nope. Not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
In the winter of 2019, the American Midwest and Northeast turned into a real-life disaster movie. I'm talking about that time when temperatures dropped to negative 63 degrees Fahrenheit. There were massive flight cancellations and power outages, dozens of injured people, and shut down schools and offices. Simply going outside became highly risky. And if you're looking for someone to blame for all this, I've got two words for you: polar vortex. That's not some scary storm, but a huge mass of cold air that's normally spinning counterclockwise around the poles. When it's summer up in the northern hemisphere, the vortex stays further north, and in the winter, it heads south a bit. The term polar vortex has been around since the late 1940s. It shows up every winter and calls it quits in the spring. But for about the last 20 years, this polar vortex has been acting weird in the middle of winter. It looks like it either splits or becomes displaced once every other year. At the bottom of this vortex is what they call the polar front, or the polar jet stream. This jet stream moves from west to east, which is why places like the northeastern part of North America get hammered by that chilly polar vortex weather. These jet streams zip along because of differences in temperature and the Earth's spin. When there's a big gap in temperatures, the winds really pick up speed. In spots like the equator, where the sun's rays are more intense, the air heats up and starts to rise. And as it goes up, it leaves behind a sort of empty space, taking in air from all around, kind of like a huge vacuum cleaner. But over at the poles, where it's way chillier, the air shrinks and sinks, forming areas of high pressure. It's like a bunch of air molecules trying to spread out, like a group of school kids on a big field. So you've got these two forces at play: warm air rising and cold air sinking. Air wants to zoom from the poles down to the equator with this setup. The jet streams tend to hang out where airplanes fly, about 30,000 feet in the air. Pilots often use them to zoom across the sky faster and save some fuel. But these jet streams aren't always the good guys, as they can bring all sorts of weather changes, like cold snaps and heat waves. When the polar jet stream is strong and cruising at about the same level as the vortex, it kind of locks in that cold Arctic air within the Arctic Circle. Every now and then, the jet stream takes a chill pill and starts moving around the planet in a wavy pattern called Arctic oscillations. This creates peaks and troughs that allow warmer air from down south to head north, and the chilly Arctic air to take a trip south. In the northern hemisphere, there are two polar vortexes, one in the lower atmosphere, known as the troposphere, and another higher up in the stratosphere. The stratospheric vortex forms as cold, dense air sinks and twirls near the North Pole. The mightier the vortex, the quicker it spins, keeping cold air locked over the high latitudes. When someone or something messes with the polar vortex, it goes haywire. Picture a spinning top. Give the table a shake and it'll start wobbling. When the polar vortex loses strength, it can't corral the cold air anymore. So, blasts of icy Arctic air surge southward over North America. The polar vortex isn't a fixed object, but more like a living being. It gets stirred up by ripples on Earth's surface, triggered by stuff like air flowing over mountains or across land and sea, all warming up differently. If our planet were as smooth as glass, with oceans wrapping all around, the polar vortex would just chill out, never breaking up. But every time a wave smacks into it, it gives the vortex a push. Sometimes, one of these waves packs enough punch to shove the vortex off the pole or even spin it in reverse. And when that happens, the temperature in the polar stratosphere can skyrocket by a whopping 50 degrees in just a week. The Arctic's polar vortex started spinning in the opposite direction in March 2024 and got scientists worried. It's one of the 6 strongest flips since the 70s. This time around, it hasn't caused any chaos. Sometimes the waves of air affecting the vortex get strong enough to split it into 2 parts, kind of like how a cell divides. They're called daughter vortices, and they even add more chaos to the mix. When the vortex splits, one chunk usually heads over Siberia, while the other cruises over North America. Once that split goes down, the jet stream in the troposphere above the Atlantic decides to take a southern vacation. That jet stream usually acts like a bouncer, keeping the chilly Arctic air up near the pole. But when it heads south, that Arctic air gets a green light to crash the party in places like the East Coast, the Midwest, and even Western Europe. The storms that usually ride along with the jet stream follow along and head south too. They take their time to get organized and catch up with the new path of the jet. So, instead of hitting up Canada like they usually do, they swing by New York and Chicago for a change of scenery. Scientists still don't know why the polar vortex doesn't mess with the U.S. Pacific coast. It might have something to do with where the jet streams hang out in each basin. Over in the Atlantic, the jet stream kicks it at higher latitudes, while in the Pacific, it's chilling closer to the equator. It might also have to do with the landscape. In the Atlantic, the air has zipped over the Rocky Mountains, stirring up waves off tall peaks that mess with the jet stream. But in the Pacific, the jet stream is away from any big mountains that could cause trouble. The recent reversal of the polar vortex is unlikely to make the temperatures drop extremely, but scientists aren't sure what's going to happen to the polar jet stream in the future. They're concerned that the chilly polar air might make more trips down to the mid-latitudes and bring along more chilly spells in the long run. So it's better to be prepared. When the news tells you there's a huge winter storm coming and power outages are highly likely, fill your bathtub with water. If you have an electric water pump, it won't work and you'll run out of water soon. Gas stations also run on electricity, so fill your car tank before the storm hits to have some emergency gas. When the storm arrives and you're locked in, put on several layers of warm clothes, thermal wear, a warm shirt, a sweater, and insulated pants and woolen socks. Don't forget mittens so the heat doesn't escape through your hands. Hang dark blankets on your windows to draw in heat. Make sure your doors and windows are closed well, and put some towels under them to prevent drafts. Your basement is probably more insulated by the ground, so it could be a good place to spend the night. To warm up the cold winter bed in your home, fill a bottle with hot water and place it in your core region under the cover. The water will heat up your vital fluids traveling through your body, reaching all the extremities and warming you up in no time. You can also wrap your pajamas around the bottle before putting them on for an extra effect. When the power comes back on, check all your appliances and electronics before turning on the main power switch. They must be unplugged to avoid power surge damage. As you turn the water supply back on, keep the taps on the lowest level of your house closed to let the air out from the upper taps. The Arctic is disappearing. In just a few years, the North Pole could see its first ice-free summer in the last 125,000 years. But a bold new experiment might turn back the clock. Scientists are refreezing the Arctic. If they succeed, they could save the North Pole. But if they fail, they could trigger unforeseen disasters. So, which way would things go? Well, here's some backstory. Deep in the Arctic, temperatures drop so low that metal cracks and winds scream across the ice. In winter, it's minus 30 degrees Fahrenheit on average. But despite the seemingly extreme cold, it's actually melting, warming 2 to 3 times faster than the rest of the planet. Now, ice is like Earth's natural mirror. It reflects sunlight back into space, keeping the planet cool. When it melts, it exposes the dark ocean underneath. The ocean absorbs sunlight instead of reflecting it, and it spreads all across the planet. This warms the planet even faster, melting even more ice. It's a vicious cycle, and if it continues, we'll reach a point where the ice won't come back. That thick, ancient ice that has covered the North Pole for thousands of years is already 95% gone. It's been disappearing since the 1980s. The ice that remains there now is thin and fragile, and when it disappears, it will trigger a dangerous chain reaction. Meanwhile, a group of researchers from a UK startup called Real Ice is out there trying to slow down or even reverse the melting of the Arctic. The project takes place in a tiny frozen village in Canada called Cambridge Bay. Real Ice wants to break the vicious cycle, and here's their plan. First, they drill through the existing ice and place an underwater pump beneath it. Then they pump seawater onto the ice surface, where it quickly freezes into an extra thick layer. Finally, they remove snow from the ice, which usually acts like a blanket, preventing further freezing. After that, ice keeps growing, stronger, thicker, and harder to melt. It's a simple idea inspired by nature itself. Ice naturally forms this way in some Arctic regions, but now scientists want to do it on a massive scale. So far, it appears to be working. Between January and May 2024, they covered around 44,000 square feet of ice, and it became 20 inches thicker on average. And in November 2024, they started a new round of tests. In the first 10 days of the trial, the ice was already 4 inches thicker. Now they'll return in May 2025 to check out how things are going. They think it's going to get between around 16 to 31 inches of it during the Arctic winter. It's a small start, admittedly, but if they can prove it works, their plan is to expand across an area more than twice the size of California, about 386,000 square miles of ice. And they're not stopping there. The big idea is to send in 500,000 underwater drones, powered by clean energy, to automate the entire process. These drones would drill holes, pump water, and refreeze the ice without human intervention. But not everyone is convinced. Some scientists think this whole idea is a disaster waiting to happen. First, they point out that saltier ice, the one from seawater pumped onto it, melts faster in the summer. So if this new ice melts too quickly, we could end up making the situation worse. Some of them also think this is a dangerous distraction from the core problem, like treating the symptoms instead of the root causes. Besides, making a small patch of ice thicker is one thing, but doing this across the entire Arctic? That's another challenge entirely. Another thing they're worried about is the ecosystem. The Arctic is one of the most fragile ecosystems on Earth. Changing ice thickness could affect marine life, disrupt algae growth, and impact the food chain in ways we don't fully understand. There's also the question of money. Real Ice estimates that refreezing the entire Arctic will cost about $5 to $6 billion per year. Who's paying for this? Right now, they're self-funded with some investors backing them. But eventually, they hope that countries, global funds, and even corporations will finance the project. Real Ice argues that doing nothing could be far worse. If we don't act, we could lose the Arctic within our lifetime. That could at least help to buy more time to fix the planet. Desperate times call for desperate measures. Now, the idea of saving the Arctic ice isn't new. Over the years, scientists have suggested some pretty wild plans to stop the melting. In 2017, there was the initial wind-powered pump plan. Physicist Stephen Desch proposed installing about 10 million wind-powered pumps in the Arctic. These pumps would pull seawater up onto the ice, kind of like real ice. It would freeze in the cold winter months, creating a thicker ice layer. The biggest problem is that someone would have to run this entire show. And what happens if something goes wrong? In 2018, there was the Glass Beads Plan, which was supposed to start in 2020s. A team called the Arctic Ice Project suggested covering the Arctic with tiny reflective glass beads. Yep, glass balls. The idea was basically to replace the ice's mirror effect. The beads would bounce sunlight away, keeping the ice colder for longer. The plan is being tested by a group of scientists working with the Arctic Ice Project. They say the glass balls are made of a material that's safe for animals. They even claim birds use similar materials to help them digest food. The glass used in these microspheres is the same material used in lab equipment and light bulbs. Sounds safe, right? Well, not so fast. There's also the environmental risk. These glass balls are tiny, and they could easily get into the ocean, impacting everything from fish to plankton. We still need more research to understand how this material breaks down in the ocean and whether it could affect marine life. But where things get really crazy is when we start talking about scaling this up. To cover just a tiny fraction of the Arctic, they would need millions of tons of these tiny microspheres, and that's just for starters. And they'd have to be working 24/7 through freezing temperatures and snowstorms. The scientists believe this could help keep the ice thick enough to survive summer and even slow the melting. But can it really work? Then there's also the Bright Ice Initiative, founded by the same folks behind the Arctic Ice Project. Instead of focusing on the Arctic Ocean, they want to use the same glass microspheres to restore glaciers. They've even tried this out on a glacier in Iceland, but experts are still skeptical. They say it could just speed up melting instead of reversing it. Now, another idea was cloud seeding with water particles. This would involve spraying ocean water into the sky itself. This would form clouds, and they'd reflect more sunlight. So, as you can see, some of these plans were too expensive, too complicated, or just straight up wild. The Real Ice's plan borrows ideas from earlier projects, but is much cheaper and more practical. Most importantly, it's working. But all this Arctic disaster is already affecting people. In the village of Newtok, Alaska, the land is disappearing. Each year, about 70 feet of the riverbank erodes, taking homes and history with it. That's all because of the erosion and the thawing permafrost. Now, these people had to move to a safer place called Megafauna, just 9 miles away. But it's a long and challenging journey. The relocation is taking years of planning, with Newtok residents already starting the shift in 2019. The new village offers better health and safety, but it's still a work in progress. Things like the school and grocery store remain in the old village, which makes things harder. Water and sewage systems are being set up, and for now, most residents are using a honey bucket system. But at least they have a chance to rebuild. It's still unclear whether these geoengineering ideas are a lifeline or a disaster. For now, we can just keep an eye on them.
A sinkhole suddenly appeared in northern Siberia. This 115-foot deep hole popped up after some weird explosion that threw dirt and rocks almost 395 feet away. Since then, 2 more mystery holes have shown up in the area. People first thought it might be connected to digging for fossil fuels, since it's not far from the biggest gas field. But the search team's radar scan suggested it was probably a natural thing. The first research trip wasn't too successful because scientists couldn't get inside and take samples until the hole's sides and the water at the bottom froze. Scientists have been wondering about what caused these holes, and the ideas varied from space rocks hitting the ground to rising temperatures on Earth. One researcher suggested that the eruption had occurred due to the accumulation of pressure. A temperature decrease is often accompanied by alterations in the volume of specific chambers. These chambers contain methane. Such craters are specific to the Arctic region. Few other areas share these particular features. They all have table-like ground ice situated close to the surface, continuous permafrost saturated with methane, and unfrozen ground. Speaking of gases, a geologist suggested that the sinkhole might have been caused by gas hydrates. These gas hydrates are also thought to be responsible for mysterious happenings in the Bermuda Triangle. The Yamal Peninsula, similar to the Bermuda Triangle, has been a place known for unexplained events. Here, residents even claim to have seen the abominable snowman. Sinkholes can pop up out of nowhere. Some are massive enough to gobble up whole buildings. They happen when rock under the ground, like limestone, starts getting dissolved by the water it contains. As the rock melts away, these big holes, or caverns, start forming. When these caverns become too much for the land above to handle, bam! The surface caves in. Ice is melting like crazy. The Arctic is warming up way faster than the rest of the world, so ice sheets and glaciers are shrinking. As these chunks of ice melt, they pour fresh water into the oceans, raising sea levels and making Earth's crust sink. During the last ice age, those massive ice sheets pushed down on Earth's crust, making it bend and sink. When the ice started melting, the crust began to bounce back. But now, the ice is melting too fast for the crust to keep up. This sinking situation creates a dangerous loop. As land goes down, more seawater creeps in, causing more erosion and flooding. What about other parts of the world, such as China? It hosts the deepest and largest sinkhole on the planet. This sinkhole is 2,165 feet deep and holds a crazy amount of space, 130 million cubic meters to be exact. They call it the Heavenly Pit, and it's not just big, it has its own mini ecosystem. 1,285 different plant and animal species can be found there. There's an ancient forest and a thick jungle of plants in there. This formation is a double-nested sinkhole with 2 craters connected by a sloping edge. When it rains, a waterfall shows up at the mouth. It feeds an underground river and cave network. When you look down from space, you'll see these deep, dark marks on the green landscape, like a footprint. Some suggested that these formations could have been left by a meteorite smashing into Earth. Others said it had taken about 128,000 years for water to carve them out. It could have snuck into underground rivers and worn away the limestone rock. It turns out, locals have known about this place for ages, but the rest of the world only caught wind of it in 1994. British explorers tried to map out its underground cave system, but it's like a maze down there. After 5 tries in a 10-year span, the team couldn't handle the rushing river and had to throw in the towel. So, this deep, mysterious underworld remains one of China's biggest geological puzzles. The next one is Crveno Jezero in Croatia. This is a huge, mysterious pit. It's not like a regular lake. It's basically a giant hole that formed when the ground collapsed into what was once a massive cave. The walls are super steep and have this reddish tint because of iron in the soil, which makes it look pretty wild. Inside, there's a deep, blue lake that's incredibly clear, but also super cold. What's really cool is that it houses a unique species of fish that's only found there. Plus, the water level goes up and down because of an underground stream. It's a bit of an adventure to explore the lake because it's surrounded by sheer cliffs that can drop rocks without warning. Let's shift our gaze to Venezuela's Cima Humboldt. This is a colossal sinkhole hanging out in a flat-topped mountain. This beast of a hole plunges down 1,030 feet. You can find an entire forest at its base. It's home to many plants and animals that only live there, like a unique frog called Stephania rhei. In 1974, people went on an exciting trip there for the first time, and they had to cut down trees so that helicopters could come and pick them up, kind of like something you'd see in an Indiana Jones movie. The second largest blue hole on the planet, known as Tamya, which translates to deep water in Mayan, is in Mexico, and that's where we're going. This underwater marvel was uncovered off the shores of Mexico's Yucatan Peninsula in 2021. But the deets about this sinkhole have just surfaced recently. It's 900 feet deep, with the sides so steep they're almost 80 degrees. The entrance to this cavern is about 15 feet below sea level. Blue holes like Tamya are these natural wonders formed during the ice ages. When the sea level was way lower, rain and other natural elements eroded limestone, creating these deep, vertical shafts. Then, as the oceans filled back up, these holes got submerged, turning into the mysterious blue holes we see today. They're called blue because the deep parts are darker than the shallower waters around them, making them look striking from above. Despite being low in oxygen, which usually makes it tough for sea life to thrive, blue holes are bustling with unique forms of life, especially bacteria. They're also gold mines for scientists because they can preserve ancient fossils in conditions you wouldn't normally find elsewhere. The team that discovered Tamya used scuba gear, sonar equipment, and water sample testing to map out the blue hole and study its water chemistry. They found that it was not just deep, but also massive, covering a surface area of 147,357 square feet at its widest point. This discovery was made partly thanks to local fishers who had been whispering about its existence. Now, scientists are diving deep into its secrets, hoping to learn more about the unique ecosystems that blue holes can host, and how they might give us clues about handling climate change and preserving marine life. Another spot is Dean's Blue Hole. This one is just off Long Island in the Bahamas. This underwater wonder goes deep, reaching 663 feet. The massive blue hole is surrounded by rocks, a lagoon, and a pristine white beach. Dean's Blue Hole isn't just a pretty sight, it's a hotspot for freediving enthusiasts. People come from all over the world to take the plunge into its crystal clear depths. There are multiple passages branching off from the main blue hole, leading into intricate cave systems and mysterious underwater rooms. It stands out also because it's the second deepest blue hole in the world, falling just behind the Dragon Hole in the South China Sea. This place is a big deal in the scuba diving world, especially since a swimmer set a world record here by diving 331 feet deep on a single breath, without any fins.